myself Dr. Priti Jagwani. I am from Department of Computer Science, Aribat College, University of Delhi. So in present series of our artificial intelligence, presently we are going through the topic entitled as knowledge representation in AI. And when we talk about knowledge representation in AI, in my previous lectures we have seen so many, we have seen actually couple of knowledge representation techniques. So let us move forward in this lecture. So when we talk about knowledge representation in AI, there are mainly 4 types of knowledge representation techniques which are to be kind of we can say followed. So first of them is the logical representation, then comes semantic network representation, then comes frame representation, and finally we can say production rules. In these 4 categories, among these 4 categories, we have already covered semantic network representation and also the frame representation, and within the frame representation we have seen kind of hierarchy of frames and inheritance of frames also. Now moving forward, let us focus on our today's topic, which is about the logical representation. So when we say logical representation of knowledge or logical representation as an AI technique to represent the knowledge, is actually a method of representing knowledge using some symbols, some rules, and these symbols and rules are basically used to describe facts and relationships respectively. So symbols are there which are going to be used to describe the facts, while for relationships we use rules. Actually it follows a structured approach that includes some syntax and the semantics, which results in kind of we can say a much of clarity in AI reasoning. So when we say the two terms syntax and the semantics, so syntax basically define the rules that validates that the expressions are fine or expressions are valid as as required, and semantics when we talk about, so semantics is actually concerned with the meaning behind the expressions. So for example, when we say there is kind of an statement which says P implies Q, but we are going to, we are writing it as PQ and then the the symbol of implication, then this any AI system cannot grasp this or cannot deduce the meaning from it, because the structure it breaks the logic, or we can say syntactically it is not correct. It should be P then the implies symbol and then Q, rather than P, Q and implication symbol. So logical syntax makes the statement clear and allows the AI system to interpret them. So this is about kind of syntax. So syntax actually is also, we can say, these are the rules governing how these statements are to be structured, where a particular kind of a connective or a particular symbol is to be placed. And when we say logic as a formal system, it also includes, so apart from this syntactical rules or grammatical rules of the system, it also includes some lexicons. Lexicon here means actually these statements. Lexicons are considered as the basic building blocks of logical expressions, while the next is syntax. Syntax we have already seen. So and it also includes, so apart from the lexicon and syntax, your logic as a formal system also includes some semantics. Semantics, as I have told you, it is related to meaning. That means it is related to the understanding of what a system represents. Then we have inference mechanism. Inference mechanism says that the rules which are to be kind of allow machines to derive new knowledge from the existing representations. Then we have for example, let us consider the 2 statements. The first statement is it's raining, and we are going to represent that with the help of the letter P, or we can say the symbol P. And there is another statement which says the road is wet, and Q is representing that road is wet. Now when I am saying the syntax, or when I am considering a syntax which says P implies Q, it means that if it is raining, because P P represents it's raining. So, it will represent if it is raining, then the road is wet, or we can say if it is raining, the road is wet. So, now as per the semantics, syntax here is correct because P implies Q we have written. So, the syntax is completely kind of we can say fine or completely correct. When we are talking or going to about semantics, semantics deals with how we understand the logical statements determining if they are true or false based on some kind of specific interpretation. So, semantics, when we say if it is raining, the road is wet. So, that semantics also here is kind of fine. So, P implies Q as per the syntax as well as as per the semantics is fine here. Semantics basically plays a key part in helping AI system reaching the meaningful conclusion instead of just applying the rules without understanding. So, application of grammatical rules or application is related to syntax, while reaching to a meaningful interpretation or reaching to a meaningful conclusion is all related to the semantics. So, syntax and semantics basically we can say are two different things. So, syntax, when we talk about it is kind of how these logical propositions are going to be organized, and these this organization of logical propositions should go kind of with hand in hand with the grammar which is available in the language in which the system is working, and it also guarantees that the systems are well formatted so that any AI system can process them efficiently. So, this was about the logical representation in which we includes lexicons, syntax and semantics and so on and so forth. When we say what are the kind of types of logical representations, so basically there are two types of logical representation. One is propositional logic, which is denoted as PL. Another one is first order logic, which is denoted as FOL, or we can say it as first order proposition logic also. So, FOPL, it could be FOPL or it could be FOL. So, when we say propositional logic, it is having some basic propositions, some basic statements, and also some logical operators which are kind of and, or, not, then they have some implications and double implications also. So, these things collectively make propositional logic. While when we say first order propositional logic or FOL, first order logic, it actually expands on PL by adding some objects, relationships, and more importantly quantifiers. There are two quantifiers, one is for all and another one is there exist. So, first order logic expands on propositional logic by inclusion of objects, relationships and quantifiers such as for all and there exist, or simply we can say exist. So, these are basically two types of logical representation, PL and FOL. Moving forward, we are going to kind of cover propositional logic today, but before going into propositional logic as the type of the logical representation, first we see that why and when the logical representation technique is preferred as compared to the semantic networks or as compared to the frames, which are other kind of knowledge representation techniques in AI. So, when we say advantages of knowledge, advantages of logical representation, so we can say logical representation is a technique which enables a very clear and precise statement of knowledge without the chances of any kind of uncertainty or ambiguity, or we can say with the minimal uncertainty and ambiguity. It also allows any AI system to infer and also to reason out based on the established facts and logical rules. This method, this logical representation method as the technique for knowledge representation is actually we can say is based on mathematics. So, it is mathematically accurate, also acceptable for AI implementation in the forms of any expert system and automated deduction and so on and so forth. Logical representation, when we talk about, is widely utilized in AI to perform some specific tasks like theorem proving. We have knowledge based systems as well as NLP, which is natural language processing. So, wherever kind of some reasoning sort of techniques are, reasoning sort of applications are involved, logical representation is having its own, is paving its own kind of different ways. But apart from all these advantages that this is mathematically accurate, used for kind of in reasonings, then it allows AI system to infer, also it enables a clear and precise image. There are some disadvantages of this logical representations. Let us see what are those disadvantages. So, when we say disadvantages, logical deduction can be computationally slow and complex, especially in case of FOL, which is first order logic, because FOL requires more computer power. We will be looking into these things into our kind of upcoming examples. Also, the logical representation does not handle the uncertainty very well, in the sense it is very hard to characterize real world scenarios where the knowledge is probabilistic or imperfect, and there are so many real world scenarios in which the knowledge is kind of, we can say, yes, it is imperfect and it is not deterministic but probabilistic. So, in these kinds of probabilistic and imperfect scenarios, your kind of yes, it is very hard to characterize this real world scenarios with the help of logical representation. Moreover, it is kind of, we can say, strict, also inflexible, which basically relies on and which demands exact definition of all facts and rules. So, there has to be kind of all facts and rules structured in a rigid way. So, it found that it is hard to handle evolving information, or even kind of the information which is flexible, because it is lying on the structures which are rigid and kind of strict, we can say, or inflexible. Also, as the knowledge base grows, because this logical representation is a method of kind of, we can say, knowledge representation. So, knowledge representation, and we also know about the knowledge base. So, as the knowledge base grows, we keep on adding more statements into this thing knowledge base. The systems becomes harder to control, because we can say there are no mechanism to handle scalability or something of that sort. Because of this situation, that as the knowledge base grows, the system becomes harder to control. It leads to inefficiencies in reasoning, and also it leads to the increased complexity. So, when we say so these were the advantages and disadvantages of logical representation, but these systems basically prioritize precision, and they are more suitable for or we can say they are ideal for deterministic environment, where they are going to use formal rules in order to model the knowledge. So, this is, we can say, kind of it is kind of a recap of what we have seen till now, which is what actually the logical representation is and what are its advantages and disadvantages. So, in short, we can say these are the knowledge representation techniques using formal rules in order to model the knowledge, and these systems also prioritize precisions, ideal for deterministic environments, and hence they are not kind of, we can say, very versed in handling the flexible and probabilistic scenarios. We have seen that there are actually two types of logical representations. So, one of them was propositional logic, another one is first order logic. So, let us move towards the first one, which is the propositional logic. So, proposition is actually a declarative statement. Your propositional logic is going to represent the knowledge as in the form of proposition or in the form of declarative statements. These declarative statements are going to be linked by kind of some logical operators, which are which can be and or not, then we have implication, and also we have double implication. So, for example, we can say there is a preposition which is termed as A, it rains, and there is a preposition which is termed as B and it says ground is wet. So, when I am saying A and B, so I will say it rains and the ground is wet. If I am going to say if A and B, then C. Now, what is C? C is another preposition which says road is slippery. So, we will be writing if it rains and the ground is wet, that is if A and B, then the road is slippery, or we can say A and B implies C. So, although it is kind of we can say it is simple to represent, it still struggles with the complex relationships, and these complex relationships are often we can say they follow the format of if condition and then conclusion kind of thing. So, for example, if an object is red and round, then the object might be an apple. So, this is kind of an a knowledge based system, or kind of some knowledge base which is being incorporated inside a system, and this propositional logic has to kind of infer the information or the new knowledge from it. With this, we can also say when we talk about first order logic in comparison to propositional logic. So, first order logic is actually as I have already told you that it extends propositional logic. It extends the propositional logic by introducing some predicates, some variables, also some quantifiers. Now, which quantifiers I am going to talk about is kind of the for all x and there exist x. Now, FOL can extend the propositional logic, and FOL can express these statements like all humans are mortal. So, all humans, so we can say for all x, mortal x is kind of we can say all humans are mortal. Now, your FOL supports nuanced reasoning, but demands significant computational resources, and this is what I was talking about when we looked into the disadvantages of logical representation, that significantly a significant computational power is required in order to process, in order to reason out all these predicates, quantifiers and variables. Also, here we can say that your legal AI tools apply logic based rules to analyze the contracts for compliances. So, propositional logic, we have seen kind of what actually this propositional logic is and how this FOL is actually an extension of propositional logic. So, when we study propositional logic in detail, we find that it is a branch of actually mathematics, to be precise, discrete mathematics, that studies the logical relationships between preposition, and these prepositions could be statements, could be sentences, could be some assertions or something of that sort. So, relationship between prepositions taken as a whole and connected via some logical connectives, and what all these logical connectives are, as I have already told you, and or not, if then else. And this propositional logic focuses on how these prepositions relate to each other. So, for example, let us take some examples of preposition. The prepositions here will be having kind of some definite truth value. Truth value as in they can be either false or true. So, let us say for example, there is a statement, the sun rises in the east and sets in the west, that is having a prepositional value or truth value as true. 1 plus 1 is equals to 2, that is also true, and if we say B is a vowel, that is not true, so we will call it as false. So, here we have some examples of prepositions. We have seen 3 statements, and we have also seen that there is a truth value assigned to each and every of these kind of prepositions. So, prepositions are so one important property of preposition is they must have a definite truth value. So, all these above statements are actually are prepositions because they have definite truth value. Now, when we say are there any statements which they don't for which they don't have any kind of truth value? So, yes, we do have, and these are actually non prepositions. So, we can say some sentences are non prepositions because they do not have any definite truth value, or it may vary depending upon the context. So, definite truth value is certainly not there. So, when we say what time it is kind of in question, we cannot say true or false, or let us say a command which says go out and play. So, that is a command again without kind of any truth value. Moving forward, if we say x plus 1 equals to 2, now depends on the value of x. So, what value of x will satisfy this, that kind of an open sentence. It depends on the value of x, whether x plus 1 will be equals to 2 or not, that actually depends. So, again it is kind of an open sentence. So, here we have a question, here we have a command, also here we have an open sentence for which there is no definite truth value. So, all these comes under the category of non prepositions. So, when we have already seen the difference between the preposition and non prepositions, let us move forward to move on to the types of prepositions. So, in propositional logic, these prepositions are the statements which are evaluated on the basis of true, or they can be marked as true or false. They are considered as building blocks of some complex logical statements. Types of prepositions, when we see, there are two types of prepositions. One is atomic preposition, another one is compound preposition. So, atomic preposition, as as the name indicates, it is just a simple preposition, and it's not, and when we say compound preposition, that's kind of an a combination of two prepositions connected with the help of logical connectives. Now these logical connectives are actually the symbols used to build compound prepositions from the atomic ones. So, there are here is a table which is given on the screen. So, we have some connective symbols, we have the word corresponding to that, then we have the terms corresponding to that, and we have examples. So, when we say the connective symbol, when we are talking about and, the connective symbol is the first one which is shown in the leftmost column. The terms is the conjunction, and we say A and B. Similarly, for disjunction we use A or B. The word is or, the term is the disjunction, and the sign is also given on this. Then a right arrow is for implies. The term here is the implication, and the example A implies B. This example we have already seen in our previous slides. Then there is a biconditional which says double implication, which is called as double implication, or we can call it as if and only if, and this double headed arrow is the connective symbol of it. And if we want to raise the example, so A double implies B, so which means A implies B and B implies A also. And then there is a small kind of connective symbol which represents the negation term, and it is more commonly known as not. And if we want to negate any preposition, we we prefix the connective symbol for not. So, A and then not A, or we can say B and then we can say not B. So, these are some logical connectives actually which are used in order to build the compound prepositions from the atomic ones. Now, since we talked about the truth value of the prepositions in all the possible scenarios, we need to look into the possible combinations of the prepositions which are joined together by logical connectives. And when the atomic preposition is joined together by logical connectives, a compound preposition is definitely formed. And compilation of all possible scenarios where a truth value is possible in a tabular format is called the truth table. So when we we need to look into the truth tables of the common logical connectives. So when we say negation, P is a preposition, negation of P will be denoted by the negation symbol P, and when translated it says if it is P then not P, or not P then P. So truth value of not P is just the opposite of truth value of P, and the truth table, which is kind of very simple, is shown here on the screen. So one side it is P, another one side it is not P. So if P is true, not P is false. If P is false, not P is true. So this is kind of very simple. So it is raining today, the negation is it is not raining today, and vice versa. So similarly for conjunction, which is two prepositions P and Q, conjunction is denoted by P and Q, and P and Q is going to be true when both P and Q are true, otherwise false. And here is the truth table of P and Q, which says P and Q, if you see that column, that is true only if and only if your P and Q both are true. In all other cases it is false. So we have seen kind of one truth table of negation, another truth table of conjunction, but we are still left with some more truth tables and other ways to look into this propositional logic, and some examples are also kind of needed to be considered. Now why all this knowledge is required? Because when we go into the resolutions, we need this whole base. So more in the upcoming lecture on propositional logics. Here is the list of references which is being used for the preparation of lecture. I will see you in the next one. Till then, take care. Goodbye.